Hello dear students, all of you welcome to Vidyan classes. Today we will discuss common solution for a system of linear homogeneous equations. Theorem on common solution for a system of linear homogeneous equation. For a system of linear homogeneous for a system of linear homogeneous equations a1x plus b1y plus c1z is equal to 0. a2x plus b2y plus c2z is equal to 0. a3x plus b3y plus c3z is equal to 0. This system is taken as equation 1. For a system of linear homogeneous equations has a common solution or non-trivial solution or non-zero solution or at least one of x, y, z is non-zero or eliminating x, y, z or the equations are concurrent implies determinant of the coefficients of x, y, z a1, a2, a3, b1, b2, b3, c1, c2, c3 is equal to 0. For a system of linear homogeneous equations, these are the linear homogeneous equations. Every factory equation are the linear equations. These equations are homogeneous since degree of each term is 1. Degree of a1x is 1, b1y is 1 and degree of c1z is 1. Degree of each term is 1, so these equations are homogeneous. For a system of linear homogeneous equations has a common solution or non-trivial solution or non-zero solution or at least one of xyz is non-zero or eliminating xyz or the equations are concurrent implies determinant of the coefficients is equal to 0. Clear? If the system of linear equations has a common solution implies as determinant of the coefficients equal to 0, or the system of equations has a non-trivial solution implies as determinant of the coefficients is equal to 0, or the system of equations has a non-zero solution implies as determinant of the coefficients is equal to 0, or the system of equations has at least one xyz is non-zero implies as determinant of the coefficients is equal to 0, or the system, or eliminating xyz from the system of equations implies as determinant of the coefficients is equal to 0, or the equations, that means the system of equations are concurrent implies as determinant of the coefficients is equal to 0. Clear? Proof? Let z not equal to 0. Since at least one of x, y, z is non-zero, let z not equal to 0. In this case, in this condition, the system of equations implies as determinant of coefficients is equal to 0. At least one of x, y, z is non-zero, let z not equal to 0. Equation 1 implies as, that means the system of equation which is denoted by equation 1 implies as a1 xyz plus b1 y by z plus c1 is equal to 0. a2 xyz plus b2 y by z plus c2 is equal to 0. a3 xyz plus b3 y by z plus c3 is equal to 0. Let z not equal to 0. The system of equation implies this. It is taken as equation 2. Clear? Let z not equal to 0. The system of equation implies this. Put x by z is equal to capital X, y by z is equal to capital Y. Equation 2 implies as a1 capital X, b1 capital Y plus c1 is equal to 0. a2 capital X, b2 capital Y plus c2 is equal to 0. a3 capital X plus b3 capital Y plus c3 is equal to 0. X by z is taken as a capital X and y by z is capital Y. So the system of equations, that is 2, implies this result. It is equation 3, it is equation 4 and it is 5. Solving equation 3 and equation 4. By Cramer's rule, it implies capital X is equal to determinant del 1 by del minus C1 D1 D2. D1 is minus C1, D2 is minus C2. B1 B2 divided by del is the coefficients of x and y, A1 A2 B1 B2. Y A1 A2 A1 A2 minus C1, that is D1 and D2, minus C1 C2. Here D1 is minus C1 and D2 is minus C2, whole divided by del. Del is equal to determinant having elements A1 A2 B1 B2 for del not equal to 0. The denominator is not equal to 0. Clear? Solving equation 3 and 4, we get capital X equal to this result and capital Y is this result. Putting the values of X and Y in equation 5. Putting the values of X and Y in equation 5 implies A3 into determinant having elements C1 minus C2 B1 B2 divided by del A1 A2 B1 B2 plus B3 A1 A2 minus C1 C2 divided by del plus C3 is equal to 0. Multiplying del in each term. Del means determinant having elements A1 A2 B1 B2 implies A3 into determinant having elements C1 minus C1 C2 B1 B2 plus B3 A1 A2 minus C1 C2 C3 into determinant having A1 A2 B1 B2 is equal to 0. Multiplying del, which is not equal to 0. Del means determinant having elements A1 A2 B1 B2, which implies A3 interchanging column 1 and column 2 will get 1 minus. Taking minus from column 1, there exists 2 minus, which gives B1 B2 C1 C2 taking minus from column 1 and interchanging column 1 and column 2, we will get A3 into determinant B1, B2, C1, C2. Taking minus from column 2, it gives B3, A1, A2, C1, C2 plus C3, A1, A2, B1, B2 is equal to 0. In the first term, column 1 gives 1 minus, and interchanging column 1 and column 2 will get 1 minus. So this will be same as this. Clear? Okay. Which implies determinant having elements A1, A2, A3, B1, B2, B3, C1, C2, C3 is equal to 0. Expanding row 3, expanding row 3, expanding along row 3, expanding along row 3, it gives the above result A3 into determinant B1, B2, C1, C2. The sign of B3 is negative, minus B3, deleting this row and column, it gives A1, A2, C1, C2. The sign of C3 is positive, C3 into determinant having elements A1, A2, B1, B2. Clear? Eliminating XYZ from the system of equations, it gives the determinant having elements A1, A2, A3, B1, B2, B3, C1, C2, C3. Hence the statement is proved. The system equation has a common solution or a non-trivial solution, or non-zero solution, or at least one of xy is non-zero, or eliminating xyz from the system equations, or the equations, that means system equations are concurrent, implies determinant of the coefficients is equal to 0, hence it is proved. Hence the statement is proved. Note: put capital X is equal to alpha, capital Y is equal to beta, and this system is taken as star. Put X is equal to alpha and Y is equal to beta in star. Star implies A1 alpha plus B1 beta plus C1 is equal to 0. A2 alpha, B2 beta, C2 is equal to 0. A3 alpha, B3 beta plus C3 is equal to 0. Elimination of XYZ, similarly, elimination of alpha and beta. It is line 1, it is line 2, it is line 3. line 1, line 2, line 3. L1 such that A1 alpha plus B1 beta plus C1 equal to 0. L2 such that A2 alpha plus B2 beta plus C2 is equal to 0. L3 such that eliminating alpha and beta from L1 and L2 and putting in L3, it gives determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Here X means alpha means capital X and beta means capital Y is equal to 0. It is a alpha beta. Is the concurrent point. We can take alpha is X and beta is Y. A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 equal to 0, A3x plus B3y plus C3 is equal to 0. That implies the determinant of the constant terms is equal to when the three lines are concurrent. Three lines are concurrent implies this determinant of the constant terms is equal to 0. Clear? Common solution, non-trivial solution, non-zero solution, or at least one of xyz is non-zero, or eliminating xyz, or the system of equations are concurrent. In each case, we will apply the determinant of the coefficients, that means the constant terms, vanishes. Clear? Clear? Okay, write down. Elements of Mathematics, class 12, exercise 5a, page number 134. Question number 11. So that eliminating alpha and beta from the equations ai alpha plus bi beta plus ci is equal to 0, I is equal to 1, 2, 3, we get determinant of a1, a2, a3, b1, b2, b3, c1, c2, c3 is equal to 0, where determinant having elements a1, a2, b1, b2 not equal to 0. Elimination of alpha and beta. Given ai alpha plus bi beta plus ci is equal to 0, where I is equal to 1, 2, 3. For I is equal to 1, the given equation will be a1 alpha, b1 beta, c1 is equal to 0. For I is equal to 2, the given equation will be a2 alpha plus b2 beta plus c2 is equal to 0. For I is equal to 3, the given equation will be a3 alpha plus b3 beta plus c3 is equal to 0. It is equation 1, it is 2, it is 3. Now solving equation 1 and 2. Solving equation 1 and equation 2. Solving equation 1 and 2. Alpha is equal to by the Cramer's rule. Alpha is equal to del 1 by del. Del means determinant having elements minus C1. It is D1 and D2. Minus C1 minus C2. B1 B2 divided by del. Del means coefficient of alpha and beta. Determinant having elements A1, A2, B1, B2. And beta is equal to A1, A2, D1, D2. That is minus C1 minus C2 by the Cramer's rule divided by del. Del means coefficient of determinant having elements, that is A1, A2, B1, B2. Coefficient of alpha and beta. It is not equal to 0 given. It is not equal to 0. It is also not equal to 0. So alpha and beta are exist. Putting the values of alpha and beta in equation 3, we get A3 alpha. A3 alpha. Alpha means determinant having elements C1 minus C1 minus C2 B1 B2 whole divided by A1 A2 B1 B2. It is not equal to 0. Plus B3 determinant having elements A1 A2 minus C1 C2 whole divided by A1 A2 B1 B2. It is beta. Beta is equal to this. Beta is equal to this result. Plus C3 is equal to 0. Taking the LCM, it gives A3 minus C1 minus C2 B1 B2, or multiplying this factor, multiplying this determinant at each term, it gives, it is cancelled, C into this plus B3 A1 A2 minus C1 minus C2 plus C3 into determinant having elements A1 A2 B1 B2. Multiplying this determinant at each term, we get this result. Clear? Taking minus 1 from column 1, minus A3 C1 C2 B1 B2. Taking minus 1 from column 2, it gives minus B3 A1 A2 C1 C2 plus C3 A1 A2 B1 B2 is equal to 0. Clear? minus 1 is the scalar. Whenever a scalar is multiplied with a determinant, it will be multiplied in any one of the rows or columns. Minus 1 is multiplied in column 1. Now interchanging column 1 and column 2, we will get 1 minus. It gives A3, B1, B2, C1, C2. The sign of the determinant changes if any two rows or any two columns are interchanged. Interchanging column 1 and column 2, we will get 1 minus. So minus minus plus. Minus B3, A1, A2, C1, C2 plus C3, A1, A2, B1, B2 is equal to 0. It is the expansion of the row 3, A3 into determinant B1, B2, C1, C2. The sign of B3 is minus. Minus B3 into determinant having elements A1, A2, C1, C2. Plus C3 into determinant having elements A1, A2, B1, B2. A3, B1, C2 minus C1, B2 minus B3, A1, C2 minus C1, A2 plus C3, A1, B2 minus B1, A2 is equal to 0. It is the determinant having elements A1, A2, A3. A1, A2, A3 A1, A2, A3 B1, B2, B3 C1, C2, C3 is equal to 0. Expanding row 3, it gives this result. Expanding along third row. A3, its sign is positive. A3 into B1 C2 minus C1 B2. B1 C2 minus B1 C2. The sign of B3 is negative. Minus B3 into deleting this row and this column. It gives A1 C2 minus C1 A2 plus C3, its sign is positive, into C3 into its minor, means determinant of this A1 B2 minus B1 A2. Hence the statement is proved. This determinant has no alpha and beta. This determinant has no alpha and beta. Elimination of alpha and beta from the system of equations represent the determinant of the constant terms is equal to 0. Elimination of alpha and beta from the system of equations gives the determinant of the elements, that is A1, B1, C1, A2, B2, C2, A3, B3, C3, whose value is 0. This determinant contains no alpha and beta. So it is the elimination of alpha and beta from the system of equations represent determinant of the constant terms is equal to 0. Hence the given statement is proved. Clear? Clear? Okay, write down. Question number 15. Eliminate xyz from the system of equations. Given a is equal to x divided by y minus z. That implies x is equal to ay minus az. That implies x minus ay plus az is equal to 0. Second, b is equal to y divided by z minus x. That implies y is equal to bz minus bx. That implies bx plus y minus bz is equal to 0. It is equation 1. It is equation 2. C is given by z divided by x minus y. That implies z is equal to cx minus cy. That implies cx minus cy minus z is equal to 0, equation 3. Eliminate xyz from the system of equations. Elimination of xyz from the system of equations implies determinant of the coefficients of the system of equation vanishes. That means coefficient of x 1, b, c. Coefficient of y minus a, 1 and minus c. Coefficient of z a minus b minus 1 is equal to 0. Elimination of xyz from the system of equations means the system of equation has a non-trivial solution or non-zero solution. Elimination of xyz is also implies at least one of x, y and z is non-zero. That means determinant of the coefficients vanishes. Applying C2 is replaced by C2 plus C3 and C3 is replaced by C3 plus C3 minus A times of C1. Column 2 is replaced by column 2 plus column 3. Column 3 is replaced by column 3 minus A times of column 1. So the given determinant implies 1, B, C. C2 is replaced by C2 plus C3, it is 0. 1 minus B. 1 minus B minus of C plus 1. This plus this. Column 3 is replaced by column 3 minus A times of column 1, that is it is 0. Minus B minus A times of B, that is minus of B plus AB. And C3 minus A times of C, that is minus of 1 plus CA. Clear? C2 is replaced by C2 plus C3 and C3 is replaced by C3 minus A times of C1. And this value is 0. Row 1 contains 2 zeros. So expanding along row 1. Expanding along row 1 implies 1 into this into this minus 1 minus of B into 1 plus CA minus this into this minus plus minus C plus A C plus 1 C plus 1 into B plus AB minus 0 plus 0 minus 0 plus 0. Clear? Minus 0 and plus 0. 1 into this is this minus this is equal to 0. The right hand side is 0, which is same as minus of 1 minus of B into 1 plus CA minus plus C plus 1 into B plus AB is equal to 0, which is same as 1 minus B into 1 plus CA plus C plus 1 into B plus AB. Minus of this is equal to 0, so this value is equal to 0. Clear? Okay. Which implies 1 plus of CA minus of B minus ABC plus of BC plus ABC plus of B multiplying this and this. 1 into B, 1 into AB, that is AB, is equal to 0. ABC cancel, BB cancel, it gives 1 plus, it is AB plus of BC plus of CA is equal to 0. Is the answer. Elimination of XYZ from the system of equations implies determinant of the coefficients of XYZ is equal to 0. That means the system of equations has a non-trivial solution or non-zero solution. The determinant is equal to 0. Applying C2 is replaced by C2 plus C3 and C3 is replaced by C3 minus A times of C1. Row 1 contains maximum 0. For easier calculation, we will expand along row 1. On calculation, it gives 1 plus AB plus BC plus CA is equal to 0. Most important question. Clear? Okay. Write down. Next question number 16. Given equations x is equal to cy plus bz, y is equal to az plus cx and z is equal to bx plus ay, where x, y, z are not all 0, prove that a square plus b square plus c square plus 2abc is equal to 1. given x is equal to cy plus bz. That implies x minus cy minus bz is equal to 0, equation 1. Y is equal to az plus cx. Y is equal to az plus cx. That implies cx minus y. Cx minus y plus az is equal to 0, equation 2. Z is equal to bx plus ay. That implies bx plus ay minus z is equal to 0, equation 3. X, y and z are not all 0. These are the system of linear homogeneous equations. Since x, y and z are not all 0, or at least one of x, y, z is non-zero, implies determinant of the coefficients of x, y, z is equal to 0. Determinant of coefficients of x, y, z is equal to 0. In this condition, since x, y, z are not all 0, that means at least one of x, y, z is non-zero, or the system of equations has non-trivial solution or non-zero solution, or the system of equations are concurrent, or elimination of x, y, z from the system implies determinant of the coefficients of x, y, z vanishes. Coefficient of x, y, coefficient of x 1 c b, coefficient of y minus c minus 1 a, coefficient of x 1 c b, coefficient of y minus c minus 1 a, coefficient of z minus b a minus b a minus 1 is equal to 0. Since xyz are not all 0, implies the system of linear homogeneous equations has a non-trivial solution. In this case, determinant of the coefficients is equal to 0. Applying C2 is replaced by C2 plus C times of column 1. Column 2 is replaced by capital C represent the column. Column 2 is replaced by column 2 plus C times of column 1. Capital C represent the column and small c represent the element. C2 is replaced by C2 plus C times of column 1, and column 3 is replaced by column 3 plus b times of column 1. B times of column 1. the given determinant will be 1CB. Column 2 is replaced by column 2 plus C times of column 1, so it is 0. Column 2 minus C times of column 2, C times of column 1, that is minus 1 plus C square. A and C times of column 1, that is BC. A plus of BC. Column 3 is replaced by column 3 plus B times of column 1, so it is 0. A plus B times of column 1, that is BC. Next, minus 1 column 3 plus B times of column 1, that is B square, is equal to 0. Row 1 contains 2 zeros. So expanding along row 1. Expanding along row 1 implies 1 this into this. C square minus 1 into C square minus 1 B square minus 1 minus AB plus BC whole square minus 0 plus 0 is equal to 0. Expanding along row 1, which implies C square B square minus C square minus B square, C square B square minus C square minus B square plus 1 minus A square minus 2 times of ABC minus of B square C square is equal to 0, which implies B square C square cancel, B square C square cancel. A square plus B square plus C square plus twice ABC is equal to minus of this is equal to minus 1. Minus of A square plus B square plus C square 2 times of ABC is equal to minus 1. That implies A square plus B square plus C square minus 1 cancel plus 2 times of ABC is equal to 1. Hence the statement is proved. Not a solution, that is proof. Hence the statement is proof. Proof or solution, which you can write solution or proof. Hence proved. Hence the given statement is proved. Clear? Clear? Okay. Write down. Question number 17. If ax plus hy plus g is equal to 0, hx plus by plus f equal to 0 and gx plus fi plus c is equal to lambda has a solution, then find the value of lambda in the form of a determinant. Given ax plus hy plus g is equal to 0. It is equation 1. hx plus by plus f is equal to 0. hx plus by plus f equal to 0, gx plus fi plus c is equal to lambda or c minus lambda is equal to 0. It is equation 2, it is equation 3. These are the given equations. It is given by the system of equations. System of equations has a solution, or we can say, or the system of equations, it is given by the system of equation has a solution, or the system of equations are concurrent, implies determinant of the constant terms. It is given by the system of equation has a solution. That means one solution. Has a solution, or the system of equations are concurrent, implies determinant of the constant terms in the system is equal to 0. A, H, G, HBF, HBF, GF, C minus lambda, GF, C minus lambda is equal to 0. Clear? Since the system equations has one solution or a solution, or the system equations are concurrent, implies determinant of the constant terms is equal to 0. Clear? Which is same as H G plus 0, H B F plus 0, G F C minus lambda. In the determinant, column 1 contains only one element, column 2 contains one element, column 3 contains two elements. So the number of determinants as a sum is 2. The number of determinant as a sum, from the properties it is clear that the number of determinants as a sum 1 into 1 into 2, that is equal to 2. In the properties we have discussed the number of determinants as a sum is equal to 1 into 1 into 2, which is equal to 2. By the sum property, by the sum we have the number of determinants as a sum is 2. By the number of determinants as a sum is 2. By the sum property, we have AHG, HBF, GFC plus AHG, HBF, plus 0 0 minus lambda is equal to 0. AHG HBF GFC. One determinant, another determinant having elements AHG HBF 0 0 minus lambda by the sum property. Which is implies as determinant having elements AHG HBF GFC. Expanding this determinant along column 2, since column 2 contains maximum zeros. 0 0, its sign is positive into minus lambda, that is minus lambda, into deleting this row and this row, that is AB minus A square is equal to 0. Clear? Expanding this determinant, we have minus lambda AB minus A square, which implies lambda into AB minus A square is equal to determinant having elements AHG HBF GFC, which implies lambda is equal to 1 divided by AB minus A square into a determinant having elements AHG HBF GFC. Clear? Clear? It is the value of the lambda in the determinant form. Find the value of lambda in the determinant form. It is the value of lambda in the determinant form is the answer. Clear? Okay. Write down.